Hello, in this video, we will introduce class abstraction and encapsulation. There are many levels of abstraction in software development. In chapter 6, we introduced function abstraction and used it in stepwise refinement. Class abstraction is the separation of class implementation from the use of a class. So let's look at this diagram here. We have this class, and this is the class contract. That's the signatures of initializer methods in the class definition. And how all of this methods initializer are implemented, that is kept in a black box. So this is the abstraction. The detailed information is hidden from the user. When the user uses the class, it looks at the class contract, see what is the initializer and what are the methods, and the user can use to develop the program using the class. So in this sense, the class defines a data type, and also the class is known as abstract data type. So because the detailed information about the class is hidden from the user. When you study in this book, you are playing two roles. You are the user using your class, and you are also the developer implementing the class. So let's look at this example here. We're going to look at the loan class. We already used the loan in many examples before this chapter. In chapter 2, we developed a program to compute the loan payment, and given the loan amount, the loan period, and the annual interest rate, we computed the monthly payment and total payment. Now, we are going to define a class for this computing loan. So this is going to be more useful because now the code is reusable. So in the early examples before this chapter, so we put this computation for computing monthly payment and total payment just in one function. And we can break them into separate functions, but the data, all this data, the annual interest rate, number of years, the loan amount, and the borrower are not closely contained. So what we do is to use the object-oriented approach, design this class, and you can create the loan object with all the data encapsulated in the loan object. So the data we have is this annual interest rate, number of years, loan amount, and a borrower. So this is the constructor. You're going to construct a loan with the specified annual interest rate, number of years, loan amount. And this is to now the get method to get the annual interest rate, get the number of years, get the loan amount, and get the borrower. And you can set all of this and set a borrower. So this is all here. And this is the get monthly payment and get total payment. So this is the UML diagram, and from this UML diagram, you can clearly see what is defined in the loan class. This serves as a contract between the user and the developer. Developer is going to implement this loan class, and the user is going to use the class by looking at this contract. So now we are going to write a test program before we implement it. So this is the test program. We're going to prompt the user for the annual interest rate and for number of years and for loan amount. And now we're going to prompt the user for the borrower. So we are going to call this constructor, invoke this constructor to create the borrower. So you probably noticed that there's a missing here. The borrower is missing in this. This was a mistake. We should fix it. So now come to here is the borrower now. And so this is the loan, and loan dot get borrower. So get the borrower now. And this is the loan dot get monthly payment. So display the monthly payment here. And now loan dot get total payment. Get the total payment. So this is how you use it. Now a separate task. You're going to play it too. You're studying and learning. So now let's see how we're going to implement this class. Here's the loan class. So this in the init method, we have this annual interest rate with default value, number of years with default value, loan amount with default value, and the borrower also has default value. So this is self. So please don't forget, this is always self here, self. And now we're going to use the private data field is annual interest rate. Get annual interest rate, and this is the get the number of years. So here is return self dot number of years. And now this is the get methods, really simple to implement. Just return self dot whatever that property name is, and set is always here self and give this value. So you're going to assign this into self dot and the property, and implement the get monthly payment. So this is monthly interest rate, the annual interest rate divided by 1200. So that's monthly interest rate in the real number. Using this formula given in chapter 2, we compute the monthly payment. Now you can return monthly payment. This is get total payment. Total payment is the monthly payment times the number of years times 12. Now return total payment. This is the important pedagogical tip. We are going to use it for this book and also for your study is when you develop this kind of programs, so you design the class. So what do we do? You first write a test program and use the loan class, even though you don't know how the loan class is implemented. This has 3 benefits. First, it demonstrates that developing a class and using a class are 2 separate tasks. Second, it enables you to skip the complex implementation of certain classes without interrupting the sequence of the book. In the future, we have classes that might be very involved, a lot of work and very complex, a lot of details. You can skip it and without interrupting the sequence of the book. Third, it is easier to learn how to implement a class if you are familiar with the class through using it. So now for all the classes development examples from now on, first, we will create an object from the class and try to use its methods, and then turn our attention to its implementation. That is all for this section on abstraction, class abstraction, and encapsulation. Thank you for watching. See you on the next video.